Let's take a look at another exponential function and how to solve it algebraically. So here we've got a radioactive substance of tritium. We start off with 50 grams. Let's go ahead and write down the equation, and it's decreasing by 5.5% every year. So that gives us a decay factor of 0.945. Raise it to the t power, where t is the time in years since we first started looking at this tritium. Okay, so we want to know what is the half-life, meaning we want to solve for T. How long does it take for 50 grams of tritium to become half of itself? So half of itself means to go from 50 grams to 25 grams. So let's use some algebra here to solve. So I'm going to divide both sides by 50. And then on the left-hand side here, hopefully you'll see that 25 divided by 50 is a half. So this is what it should look like when we're looking at half-lives of radioactive substances. And so on the right, as soon as you have just a base raised to an exponent, we can take the natural log because the logarithmic function is the inverse of an exponential function, but then whatever we do to one side of the equation, we have to do the same thing to the other side. And then now I'm going to apply the power rule for logarithmic functions. So the power rule for logarithm says that the natural log of a base raised to the power of t is the same thing as t times the natural log of that base. And so we can rewrite the right-hand side like that. And then on the left-hand side, let's go ahead and bring down the natural log of 1/2. And so here, my last step is to divide out the right-hand side by the natural log of 0.945. That cancels out. And then again, whatever you do to one side, don't forget to do the same thing to the other side. And then put all of this into your calculator. So t is equal to the natural log of 1/2 divided by the natural log of 0.945. And you can see here on the calculator on the right, when you put that into your calculator, we get 12.25, so 12.25 years.